When the procedure will going to be start with this object oriented design, it will start with a examination of the real world things. All the requirements, whatever is given by the user or a stakeholder, everything will going to be validated. So if you consider a system, there is no only one object. It will going to be a collection of objects. At that time, this will going to be executed sequentially, one by one or in a parallel manner. Hello everybody, a warm welcome to one and all. Welcome back to the session 3 of Unit 3 of B.C.A 6th semester subject called Software Engineering. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So in the Unit 3, we are dealing with the design, concepts and coding, right? So in our previous session, we had discussed regarding this modular design. So we got to know that why we require this modular design. So under that we have a functional independence and also we have learned regarding information hiding, right? So after that we got to know the strategies of design. It can be top-down approach or a bottom-up approach, and also we have discussed regarding the difference between structured and object-oriented analysis. So C programming comes under structured analysis and C++ or Java program, all those things comes under this object-oriented analysis. So in our today's session, we'll continue with this function-oriented design. So now we have analyzed, then how it will going to be designed, what are the methodology it will going to implement there, that is what function-oriented design, and also we'll see about this OOD, that is object-oriented design. After that, we'll see the difference between those two, then we'll see about this designing of verification and validation process. So what is verification, what is validation, how the processes will going to be happen, that is what I will be discussing in my today's session. Let me get into the first topic, that is function oriented design. As the name indicates, we are doing the design that will going to be based or oriented on the functions. So as we all know that in earlier, so functions are nothing but methods, right? So that will going to perform some of the operations. So when it is developing or when we are designing any of the module or any of a set of instruction to perform a exact task without bothering about any other thing, then we are going to say that as a function oriented. So in this function oriented design, it will mainly focuses on the function of the program. So what is the main function of a program? What are the activities it will going to perform? So that will going to be based on that function of a program, and also it mainly concentrate on the stepwise refinement. So at a single shot we won't do any of the design here, it will like a refinement. So each refinement will going to give you the elaboration of a system design. So at one shot we won't be able to do all the designing of an entire system. So in first part I will do some other activities, or we will going to incorporate some of the function. When it is dividing or when it is taking a next refinement or iteration, at the time another features will going to be added. For that reason, refinement will going to be considered as an elaboration of a software development here. So that refinement will going to be based on the iterative procedural decomposition. So it will be iterative. So we are going to incorporate one feature and next we will take one more feature. That is what iterative. It is not static. And also this stepwise refinement is a top-down strategy. Already we know, right? We have one module. So this is what identification of a main component. So that main component will be divided into number of sub-component. So when we are reaching to the next and next level, at that time refinement is taking more. That means when we are doing this refinement, at that time we are adding more detail to the system design. That is what you can understand, where a program is refined as a hierarchy of increasing levels of details. So when the levels of details are increasing, at that time we are going to get the more detailed data about a system design. And also you can see here, and this will going to start with a high level description of what the program does. So we will get to know what program will going to be do, and After that, each refinement will going to give you the elaboration. So when we are reaching next and next level, at that time we can get more detailed version of the system. So then in each step we take one part of our high level description and refine it. So here we will concentrate on this one and I will refine this. Again, I will reach to the next level. Then we are going to do the same thing until we reach to the last step. So that mainly refinement will be considered as a process of elaboration. We are elaborating it. We are giving more details to the existing system. And also it needs to be proceed from highly conceptual model to lower level details. So if you just look into this, we won't be able to understand, because here in the level 1 abstraction will going to be very high, but when it reaches to the next level, that is level 4 here, at that time detailing will be very high. So for example, if you consider the computer as an example, simply subjectively I am going to say that as a computer, but if I am saying that is microcomputer, mini computer, under that what is the processor and what are the speakers we are using, what are the input and output devices we have, what is its configuration. So when we are moving further levels, or when we are reaching it in the more hierarchy, at that time detailing will be high. Then when I should stop this detailing or refinement? So each module is done until we reach the statement level of our programming language. So when we are able to write that code in any of the programming language, till that detailing we have to do the segmentation, or we have to do the hierarchy here. This is regarding what? Function oriented design. And also next what we have? Object oriented design. So here in the previous one, that is function oriented, there we will get to know how to do the function or how refinement will going to take place. Then what about this object oriented design? Here all the real world element will going to be considered as object. So we are doing the designing for that object. So main focus will be on the object than the function. As I taken an example earlier, we have a 2 plus 3. So in the function oriented design, they will bother how to do this addition. So they will bother about the process and they won't bother about the data. In the object oriented design, we will mainly concentrate on the data rather than the procedure or a function, so that it's the result of focusing attention not on the function performed by the program. We won't bother how we are going to add. Instead of that, we are focusing on what we are adding. That is what? But focuses will be on the data that are to be manipulated by the program, so that it will be considered as what? Function orthogonal to the function oriented design. It is just a opposite to this function oriented design. That is what? Object oriented design here. And we are going to start, or when the procedure will going to be start with this object oriented design, it will start with a examination of the real world things. So first I need to identify which is the object, then what it will going to perform, what is its characteristics, and what are the methodology it will going to follow. So that will going to include the characteristics individually in the terms of their attributes and behavior. Remember, attribute specifies the properties. If I consider this pen, or if I consider a bangle, then what are its property? It will going to have a color, it has shape, it has some cost. So all those are the properties. Then behavior specifies the methods or operations that it will going to perform. So it will going to spin, we can roll it, right? Those are the methods or a behavior. So you can consider any real world object, any real world entity as an object, but it must include its attributes along with a behavior. Attribute specifies the properties and behavior specifies the methods that it will going to perform. And also here, objects are independent entities that may readily be changed because all the state and the representation information is held within the object itself. So if you consider the object itself will going to have a properties as well as the behavior. So with those two criteria, we can specify any of the real world element as an object, so that it will going to be independent entity. It is not depending on anything. So why? Because if I consider this remote, at the time it has its own properties and behavior. It is not depending on any other thing. That's why it will be independent entities. Fine. And also object may be distributed and may execute sequentially or in parallel. So this objects. So if you consider a system, there is no only one object. It will going to be a collection of objects. At that time, this will going to be executed sequentially one by one or in a parallel manner. And also this object oriented technology or object oriented design is based on the three keywords, that includes objects, and also we have a communication, at last we have a methods, right? So we have objects, communication and method. Then what about this object? As I told earlier, if we have any real-time element or real-world entities, then that will be considered as objects, and that will going to have its own behavior along with the properties or attributes. So that software packages are designed and developed to correspond with real-world entities. So what we have here, that is what object. It comprises of real-world entity that contain all the data and services to the function as their associated entity messages. If you take any of the object that comprises of a data and services, that services specifies the methods or a behavior and data specify its properties. And next what we have, next component, that is what communication, right? So in the communication, if you consider any of the system, it is not going to comprises of single object. Instead of that, it will going to have n number of objects, and each object will going to have its own properties, and also it will going to perform some of the operation. That is what behavior, right? So then how communication will going to be established between one object to another object, how the exchange of data is taking between all the objects, that is with the help of this communication mechanism. This will going to be established that provide the means by which object work together. So if there is no communication between one object to another object, if there is no exchange of messages between the objects, then we won't be able to do the object, we can't bind the objects together, then we won't get benefit of all the combining of all the objects. That is why communication is also going to be very important. And also we have a methods. So methods represent what is its behavior, what are the operations that it will going to perform or it will going to follow. So these are the services, that means what is it's providing. So that object performed to satisfy the functional requirements of the problem domain. So when we have a methods, that method should lead to the solution of a problem domain whatever we are facing. So for that, in order to build and establish, we have a communication. In between what we are establishing communication, that is for the object 1, and here we have a object 2, here we have a object 3. Each object will going to have its own behavior and properties, and there must be a communication between all the objects. Then only it will be easy for the designing of that object oriented methodology. So here object will going to request the services of the other object through messages. How the establishment of a communication will going to take place? With the help of message. One object will going to share a request, or it sends the request to another object with the help of this message. So this is related to what? Object oriented design. So now here you can see the difference between object oriented as well as that function oriented design. So this part is related to function oriented design and this is related to object oriented design. So this first column specifies on what basis we are making a comparison. First one is related to abstraction, right? So it's a feature where it will going to specify only how essential features. It specifies or showcase only essential features by hiding the background details. Then how abstraction will going to be performed on the function oriented as well as in the object oriented. Already we know that we have two types of abstraction. One is function abstraction and another one is data abstraction. So in the function oriented design, it will be going to have a function abstraction. So the function abstraction will be there in the function oriented design. But in this, so in the object oriented design, so here abstraction is not on the function but it will going to be based to the real world element, that is what? Object or a data. So those are of the two types. Here function oriented is related to function abstracted and also OOD is related to data abstraction. Then how about this function? Functions are grouped together by which higher level function is obtained. So here in this function oriented, so we are going to tie all the functions together to get the higher abstraction level, or to get the higher level of function we are going to combine all the functions here. But in the object oriented design, functions are grouped together on the basis of a data they are operate, since the classes are associated with their methods. So this will going to follow the bottom up approach. So with the help of that we are going to do the designing. This is what the difference. Along with that we can see some more difference here. State information. So what information it will going to fetch? In this approach, the state information is often represented in a centralized shared memory. So we are going to get the details about this function oriented design in the centralized shared memory, but here we won't get that information in the centralized main memory. That means it's not represented in the centralized main memory, but it is implemented or distributed among the objects of the system. So all the information of that state, in which state this design is performing or in which state the design is there. So that state will going to be specified by the object itself, but here it will going to be stored in the shared memory or a computerized centralized shared memory. Then what kind of approach this is? It is related to top-down approach, and it is just a contradict to that. It is bottom-up approach. Already I have written that this is bottom up and this is top down, right? Then begin basis. On what basis we are going to do this function oriented design? At what time it will going to be invoked? So begins by considering the use case diagrams and the scenarios. Just by looking into use case diagram and scenarios, we can start doing the functions. But in this object oriented design, it will be specified or start with the invocation of a identifying the object and classes. So where this object will going to belongs, to which class it is belonging. That is based on the basis of that beginning. Next we have a decompose. When we are going to do the decomposition or a segregation in the function oriented design, we decompose in functions or a procedure level. It will be based on the function or its procedural level. Here we are going to do the decomposition in the class level. So here class in the sense you have to go back to the object, class, abstraction, data encapsulation, that methodology you have to follow. So for example, if this is one object, right, if I consider this real world entity as one object, if I have 10 numbers of this same pen, at that time if I consider all together, then I can consider that as a digital pen class. So if you pick any of the pen out of that, each pen will going to represent as a object. If it is a collection of objects, then we can consider that as class. So in this object oriented level, decomposition will be at the class level, but here it will be in the function or a procedural level. Then where we are going to use this function oriented design and OOD? So it will be mainly used for the computation sensitive applications. So when the computation is sensitive in any of the application, there we are going to have this function oriented design, and this OOD or object oriented design can be used in where we are going to do the in evolving system which mimics a business or a business case. So in that situation, in that application, we are going to use this object oriented design. I hope you understood regarding the difference between function oriented as well as object oriented, and it is very important for 15 or 10 marks question. All those differences, whatever you are getting in the chapter 3 or unit 3, all those are important. Let me move to the next topic, that is regarding design verification and validation process. So with the different methodology, by using different strategy, we have designed, right? So there I have to do the verification as well as validation. So in the verification, I need to get the requirement from the user. After the verification, we have to do the implementation. Designing has to be done. Once it is designed, then I have to do the validation. So that is a process of checking, are we satisfying all the requirements of a customer. That is what verification and validation process. Already you know about the V model, right, which we have already learnt in the unit 1. So in the unit 3 we are going to focus on this design verification and validation. So here validation is a process of evaluating the software product for the exact requirements of end users or stakeholders. So against the requirement of the end users or stakeholders, we are validating this, or we are evaluating this software product. Are we getting the correct product which is based on our requirement? So that process is called what? Design validation. Then for what purpose we are going to do it? So mainly to test the software product after the development to ensure that it meets the requirements in terms of application in the user's environment, whether it is satisfying the requirement of a user or not at the time of after the development. So when we are developing any of the system, at the time whether it is following or it is satisfying the requirement of a customer or not, in order to check that we are going to have this design validation. And also you can see here mainly it will going to take the user requirements first. After that will be given as a input for the designing. So by doing some process it will be converted into design output. Then at last we can get the product as a resultant, right? So after when we are getting this product as a resultant, that will be given for the design validation, right? So in the design validation they are just going to check all the requirements whether it is satisfying the user requirements or not. If not, again it will going to be sent back to the user requirement. User can have their own requirements, or at the time of given of a user requirements, there also we can do the design validation. This will going to be bi-directional anyway, right? Then validation is mainly concerned with demonstrating the consistency and completeness. Very, very important two words that you need to remember here. Validation is concerned with demonstrating the consistency and completeness of design with respect to the user needs. Mainly we are all doing it in order to satisfy the requirement of a user in the terms of designing. So how the product should be? So it must be consistent in nature. For example, if they are building calculator at the time of 5 p.m. if I am typing 2 plus 3, if it is giving 5, and if I check it in a midnight 2 plus 3 as 7, then there is no consistency, right? And it must be complete in nature. It has to satisfy all the requirements of a customer, and whatever the requirement has been satisfied, that should be consistent in nature. So in order to do that, this validation will going to be used. So that mainly we are building a version of the product and validate against the user requirement. Based or against the user requirement, we are validating all the product whichever has been built or developed. And also here you can see that mainly this represents the design validation process, right? We wanted to do the product development. So in order to do that, first what we are going to do in the user environment, everything will going to be set up, and test site or prototype or simulator will be used in order to do the setuping. After that, design input. So design will be given as an input, procedure as per user requirement. That design will be given as an input. After that, whatever you have seen in this example, same thing will going to be done in the vertical way here. So that after that performance or some operation, we can get the design output. Even that is also in any of the physical format. It can be image or it can be some video stream. In the audio stream, that will be in the physical format. After that, they are going to validate the design with user requirements until it satisfies its needs. So that all the requirements, whatever is given by the user or a stakeholder, everything will going to be validated. After that, if every requirement has been satisfied, then it won't come here again. After once the product is developed, at that time successfully validated design goes for the production. Then it will be sent as a successful validation. At last, it will be given for the implementation. This is how this design validation process will going to work. So once all this design validation process got over, that needs to be documented there in the documentation form. They are going to do they are going to document everything against the requirement of a customer or a stakeholders. Then what is the need of doing that? Mainly we have to showcase that resultant in a physical format, right? So that can be anything. Here we'll discuss. So the purpose is to prove with the objective evidence that product satisfies the documents of the user needs. It mainly specifies that whatever the requirement which is given by the customer or a stakeholder should be satisfied by the developed software or a system. So here objective evidence is a physical proof of the output. So here we only bothering about how it will be resultant, what is its resultant, whether it is in the terms of image or a text audio file. So mainly that indicates that the procedure has been accomplished. That means whatever the requirement taken by the user should be produced as a resultant. That resultant can be image, text or a audio file. But why we have to do this? In order to have a proof that all the objective evidence which has been given as a requirement by the stakeholder or a customer got satisfied. And also this objective evidence process will consistently examine that product meets the predefined requirements. If it is not satisfying the requirements of a customer, again we have to do the refinement. So that refinement process is again a elaboration process. Mainly this process will going to include testing activity, inspection activity, analysis and also so on. So all these activities will be incorporated mainly to ensure that all the requirement of a customer should satisfy. That is what the reason of doing this system verification or design verification and validation process. So in our today's session we got to know regarding this validation process. Then how about this verification? Let me discuss in my coming session. So there we're going to see about this design verification and also we'll see about the difference between the design verification and validation. So if it is verification here and here it is validation, we'll see the difference. Along with that we'll see what are the verification process we have and also we'll see what are the validation process we have with the help of advantages of design validation as well as verification. I hope you all understood and enjoyed my today's session. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.